Hi guys, this is Smartphysics problem. I'll be quiet in this video because I'm at the library. Anyway, this is a sphere on incline problem. The problem here, we have a sphere here. There's the incline, they give us the theta, they give us the mass, they give us the radius, they give us this distance. From here to here, this is the d. So they ask us one bunch of questions, and I'm gonna go of it on the opposite way. For the first question, they're asking us what is the KE translation over KE total, so the kinetic energy total. Okay, I'm gonna go about that on the opposite way. Okay, so the first question, it's asking KE trans over KE total. The second question they're asking about the KE trans, and the third one they are asking about the V. Alright, so this sphere is going to rotate, it's going to go down to here, to this point. So what can we say? We can say, since it's rotating and it's not slipping, we can say that the total energy for the system when it's going down is equal to potential. So this is UK plus UR. This is the potential energy, kinetic energy, rotational energy. So the total energy will be equal to, when it's at this point, all the energy will go to rotational and will go to translation motion. Okay. So what is UK? UK is half mv squared. Okay, and the UR is equal to half I omega squared, and we can change this since omega equal V over R, and the I for the sphere, you have to memorize it as 2/5 mr squared. Alright, so the UR will be half times 2/5 times r squared, and the omega will be times v squared over r squared. We can cancel the r's here, so the VR will be equal to 2 over 1/5. Will be equal to 1/5. Okay, 1/5 m VR squared, v squared. So let's sum them up now. So the potential will be equal to 1/5 mv squared plus half mv squared. So we're just adding the fractions now, and this will sum up to 7 over 10 mv squared equal the potential. Okay, what's the potential? How can we figure this out? The potential energy, they gave us the theta. Oh, what is the potential first? Potential is mgh. Okay, so we need the h. The h is not this d, it's this h. It's the height, perpendicular height from the ground, or where you took the potential as 0. Okay, so how can we find h? We have the d. So sine of theta will be equal to h over d. So h equal sine theta times d. And then you you'll get a value for this. Okay, then you substitute this h back in here. Okay, this is where you get the potential. Okay, so once you get the potential, PE equal mg, then sine theta d. You substitute this potential thingy value you got, you substitute it here. Okay, then you do the v equal v squared equal 10 PE over 7. And then you take the square root of this. And here you get the v. Now this is your value for v. Once you get this value, oops. Right. Once you now get this value, you answered number 3 here. Because they're asking about v. Okay. And for number 2, they're asking about the kinetic energy translation. And this one is half mv squared. Okay. So you have the v and you have the mass, you can get that easily now. Okay, so this is number 2. So going to number 3, they're asking about KE translation over KE total. Okay, so what is that? Okay, we got the value for this just a minute ago. And the kinetic energy total is the same as the potential total because energy is conserved. Okay, so it's the same value as the PE that you got. You substitute it here, and you'll get a number. Well, most of us, I think it's 1.74. I think. Anyway, I'm not giving you answers. So number 4. Oh, there's number 4 in it. Anyway, they're asking. Suppose there is no frictional force between the sphere and the incline, or what is the kinetic energy of the sphere? What's the translational kinetic energy of the sphere at the bottom? They're saying if there was like no friction, and since there's no friction, there's no rotational. So the potential that we said from the beginning was UK plus UR, as we said here, back here. But since there is no friction, that means that there's no torque, which the sphere won't rotate. So the R will go to 0. That means that the potential will be equal to the kinetic energy, the translational kinetic energy. So this will go to 0. So the value you'll get for potential energy, just substitute it back to the UK. Alright, I hope this helped. And good luck, buddy. Sorry if my voice you can't hear it, but I'm at the library.